So now we finished discussing depth perception. We're in the last section on vision, and this is the section of perceptual illusions. And so perceptual illusions is the idea that our brain interprets things that are not real. Our eyes give information to our brain, and our brain interprets things that are not true to be there. So if you look right ahead at this illustration with the one white square with lots of little black squares in it, if you look at it, you may see something imaginary. You may see at the corners of the black squares little gray dots appear. These gray dots do not exist. They are completely imaginary, but you continue to see them even when you know they're imaginary. Even when you try and tell your brain they're imaginary. If you stare with your fovea at one intersection, they may disappear, and in your peripheral vision, they may reappear. And that's because we have a better time controlling what's going on in our central vision and double checking and proofing it. But as soon as you move to another intersection, they appear. So that's one type of perceptual illusion. There's many types of visual perceptual illusions. We can't go through them all, but we will discuss a couple subtypes and explain some of the phenomena that aid into it. So the first type is the ambiguous images. So in ambiguous images, what we're looking at here is there's lots of information in an image, and our brain has to mute some of it and pay attention to some of it. We have to kind of ignore some of the stuff and pay attention to some of the stuff. And even when we're paying attention to it, it may not perfectly work, but we lean into what we want to see. So there's lots of images here. In this one, we may see a white vase, or we may see two faces looking at each other. Or you could see both ways, of course. But either way you look at it, you have to cancel out one of the things. If you want to see the vase, you have to make that be what's called the figure, or the attentive piece. And you have to make the faces be the ground, or the inattentive piece. This one here is a very famous illustration. Do you see a young woman with her head turned, or do you see an older woman with her chin buried into her fur coat? To see the young woman, what we'd see is the nose is looking away, there's one eyelash, there's an ear, there's a jawline and a chin and a necklace and a bit of a chest. For the old woman, what we would actually see is there's an eye, and this is a nostril with a nose, and this could be a wart on the nose with an eyelash, and this is a mouth with a chin. Now, many people say the old woman is not as realistic as the young woman, but it's the idea that you could suspend reality for a moment and say, oh yeah, I could see that as an old woman. It's like cloud gazing. Could you see it happen? Same thing as are these blue arrows on a white background or white arrows on a blue background? Of course, it is both, but when you first look at it, your brain has to choose which one to mute and which one to pay attention to. So the part that's being paid attention to is the figure, the part that's being muted is the ground. And the last one, of course, is the duck versus bunny. So this could be a bunny, although its mouth and nose may look a little bit atypical, or this could be a duck, although its beak is also a little bit atypical. Either one you're paying attention to, you have to suspend reality a little bit and ignore the parts that don't make sense and really hyper-focus on the parts that you want to make sense. So it's important to understand none of these images are any of those things. They're just black and white images, and your brain is interpreting it. We can also do this with impossible figures. So of course with this cube up here, the one on the left could make sense if it's just a three-dimensional drawing of the cube. It could also be ambiguous. Do you see the front of the cube as the upper right-hand portion, or do you see the front of the cube as the lower portion? You could see that in two ways. But once we draw these bars on it, it becomes quite impossible. There's no way for this edge to be in front of this edge. And so that one overlap makes this into an impossible figure, and our brain will have a hard time processing it. Finally, we have some impossible figures down here. If you're paying attention just to this end of the figure or this end of the figure, it seems to make sense. But when you try to pay attention to the whole figure, it no longer makes sense. So because of this, ambiguous figures, we have to pay attention to what we make the figure, what we make the ground. When we try and pay attention to the whole, we realize it's pretty nonsensical. Another type of illusion is a closure illusion. These were most famously understood by Gestaltian psychologists. And so I just have two to kind of give a brief example. But this is the idea that what we're looking at is, in this image, is really just a few edges and then what I almost think are little Pac-Man faces. There's no diamond on this. There's no diamond shape on this picture. The white in the center is the same white that's on the edge, but our brain will make the white in the center seem more bright. We will want to see a diamond shape here. Even though there is no diamond shape here, we will want to see that. And in this image here, you may see this as a sphere with lots of little spikes. And they can get more complicated than that, but it's the idea that we're no longer processing things for what they are. Our brain is making assumptions. So this really becomes the difference between top-down versus bottom-up processing. Whether our brain is making conclusions about what it expects and we find what we're expecting, or if we're looking at what things really are and then telling our brain that. And so this is really a top-down effect. And of course, the third type of illusion is the color illusions. And so color illusions happen because of the context at which objects appear. We're constantly looking for shadows and contextual cues to give us information. And when someone intentionally makes a color illusion, it usually defies when we would typically see these colors. So for instance, let's start over here. This gray bar in the center, although the right-hand side looks darker than the left-hand side, which looks lighter, this bar is all one color. If you were to put this in Microsoft Paint and draw out the different colors, we'd find that here where my arrow is and here where my arrow is actually the same color. What's different is the background. So the background changes from dark to light, but the bar stays the same color. And that may be really difficult for us to understand because it's all the same. Another one that you may have difficulty overriding is that the square that hosts the A and the square that hosts the B are the same color. You might start screaming at me and say, no, it's not. But it actually is the same color. The difference here is this square here has the shadow, and the light side is facing A and the dark side is facing B to make this illusion that B is a lighter color, but it's in the shadow. B is in the shadow, and B in the shadow is the same as A not in the shadow, if you will. And so this background is the exact same as this background. You can extract these and check them out for yourself. They are on the Wikipedia website that you can download and play around with for color illusions. Now, some very popular color illusions, of course, was the dress phenomena. Now, this dress phenomena, is it gold and white? Is it white and black? Is it blue and black? The dress, of course, is blue and black, but for many people when they look at this image, because of the contextual cues of the whiteness over here, they think that it is indeed white and gold. But it's because of the flash and because of the misinformation. Now, oddly enough, some people, when they only see it from the top part of the image, it really looks white and gold, and when they only see it from the bottom, it really does look blue and black to them. So it is a fun illusion. Another one is the sneaker. Is it pink with white trim, or is it gray with sort of teal or cyan or aqua trim? And so which one is it? Of course, the sneaker is actually pink with white trim, but because of the lighting, it may look gray with teal trim to some people. Okay, and the last one that I just want to show you is what color are the strawberries? Are the strawberries blue or the strawberries red? The strawberries, in fact, are blue in this picture. They look red because they are less blue than everything else in the picture. But I assure you, if you were to take this image and take an eyedropper tool in your photoshopping software of choice, basically what you would find is that even in the most reddest parts of these strawberries, the color is actually blue. It just is less blue than the plate in the background. So our brains interpret them as red. So this is very much a top-down rather than bottom-up approach because our brain is seeing what we want to see and not what things actually are. So that's the basics of color illusion. Then, of course, we have sizing distortions. So sizing distortions, there is some cultural variations, of course, in all of these illusions. And sizing distortions really made that clear, especially with the idea of different shaped lines. So this illusion over on the left, which line is longer, the left or the right? Well, they're both the same size. But many people who grew up in houses with sharp corners would perceive this one as longer. And that's because if you were to see these types of lines in a house or in a structure, we would expect that these angles, these outward angles, are further away than these inward angles, if you will. Some other sizing illusions, of course, is which shape has the longer top line? Is the top line in this shape longer? Is the top line in this shape longer? Of course, we're studying perceptual illusions, so we know the answer is they're both the same size, but your brain may say the top one's longer. The contextual angles around it are making us perceive this to be a bigger shape. With regards to the orange circles, which orange circle is larger? Many of us would assume it would be this one, and your brain may think it looks larger even while you're looking at this and knowing they're the same. You may have to constantly override yourself because your sense of perception is going to say that the one on the left is smaller. They're, of course, both the same size. And then the last one I want to talk about is the shepherd's tables. This is one of the hardest ones to believe in my experience from teaching this course. And so these tables, what may not seem true but is true, is that the height of the table on the left is the same as the width of the table on the right, and the width of the table on the left is the same as the height of the table on the right. That is, if you were to actually measure them, and you may say it's due to your widescreen or projection or what have you. I actually have it in a book as well, and when I take the book to class, students say I'm bending the paper, and I will take the book and pass it around, and students will measure it with rulers they get out of their own backpacks. It's true. It's true. If you were to measure this with your hand, you would find that they are the same. So this is a really cool phenomenon. Of course, the legs of the table are aiding in this, but not including this lip, I should say. So only the top part of the surface. So this is the edge of the surface, so not including the edge, but just the top surface of the table. They are the same, and so it really does throw a lot of people off. It is a hard one to understand, and it's a great illusion. So again, this is what's happening. We're looking at the relative placement. We're looking at the height in our visual field. We're assuming things are further away in some instances. And this sense of linear perspective is telling us about depth, which is really tripping us up. And the last type of illusion we'll get into here is the movement illusions. And so movement illusions is the idea that although something is a static image, they are not moving GIFs. I'm not able to put moving GIFs into Prezi, so none of these are moving. None of these are changing. They are all static. But even though they're static, you may see them as changing. And that's because based on where your focal point is, based on where your fovea is, in your peripheral vision, you're detecting contrasts, and they are alluding to some sort of change to you. These contrasts, in this one here, this may be the hardest one to detect, but if you can see it, it might appear to be that even if they're not moving, it may appear as though the lines are not straight. It may appear that some lines are getting bigger and some lines are getting thinner. All lines in this image are actually straight, like straight horizontal or straight vertical. They don't all meet up, but there's no curved lines in this image whatsoever. In this image here, you might see a bit of a spiral or clockwise or counterclockwise spinning effect. Not everyone can detect it, but if you can, that may be what you see. In this one, you may see a bunch of like cogs turning. Although not everyone can see it, you may detect it. And if you hold your vision on one of the wheels, it's not moving, but the other ones in your peripheral vision may be moving. And the final one, this is a bit more of a complex movement, and you may see a bit of like cylinders turning or cans turning on an axis, if you will. But nothing's actually moving. This is not a GIF, it's not illustrated, it's a very basic static image. And so that brings us to the end of discussing the eye. I hope you've enjoyed learning about our most advanced but most corrupt sense.